Alright, so in this video we're talking about graphing linear equations in 3 variables. So we're stepping it up to 3D. Before, everything you've done in Algebra 1 and up to this point has been in 2D. We've been on the grid. Now we're going into 3D, so get your glasses ready just in case. Alright, so we know that in 2D, on the ordered pair, in the ordered parallel, it's like x comma y. Well, obviously then we need, for 3 variables, we need what's called an ordered triple. So this is going to be called an ordered triple. Because we have 3 variables. Now x and y stay the same, but now we add z. So just alphabetical order. All right, now here x represents how far forward, if it's positive, or backwards, if it's negative, you're moving. Y is representing how far to the right you're moving. So how far to the right you're moving, and I'm doing it to your right, not my right. And then how far to the left you're moving. Okay? So again, I'm doing it to your left, not my left. Now z tells you how far up or how far down you're going. So z is your height, how far up and how far down you're going. Okay? So this measures the height. Sometimes this is called depth. So let's put depth over here. So if you think about a pool, how deep it is, that type of thing. All right, so this is, again, it's called an ordered triple, so we have already answered that. And in 2 dimensions, the x and y coordinates, or x and y axis, divide the grid, or the coordinate plane, into quadrants, first, second, third, and fourth quadrant. But now what happens with the x, y, we're also going to add the z-axis. We're going to divide the space that we live in, the 3-dimensional space, into octants. So a first octant, second octant, third octant, fourth octant. And then on the lower hemisphere, we're going to have another 4 octants. So octant, Greek word, just means 8. Here's a picture of the coordinate space. Have the x-axis. You kind of got to think about this 3 dimensions. Positive x comes out forward towards you. Negative x goes backwards into the screen. Positive y goes to the right. Negative y goes to the left. Positive z goes up. Negative z goes down. So here my ordered pair. So this is my x, y, and z. So negative 5 tells me I go backwards 5 units. 1, 2, 3, 4, 5. Y tells me, y equals 3 tells me I go to the right 3 units. 1, 2, 3. And then z equals 4 tells me I go up 4 units. So 1, 2, 3, 4. And then, so my ordered pair is kind of 3-dimensional space. You see I kind of use these little lines to help guide me. It lives right there in that space, up in the air somewhere. Okay? I would strongly suggest you maybe copy this axis down, print one out offline, and just pick some random ordered triples and try to graph them yourself, okay, until you understand what's going on. And then this is just a picture of the first octant. Like I said, there's 8 octants. I'm not going to go through all 8, but the first octant is where, it's kind of like our first quadrant. First octant, first quadrant. Here, right here, this is the xy plane. The xy plane, I'm just going to shade it. Okay, it just uses the y-axis and the x-axis. Okay, so it's kind of like our floor. Okay, the xy plane is kind of like the floor. The YZ plane, let's shade that one in blue. YZ plane, shade that one in blue. Okay, it uses the z-axis and the y-axis. That's kind of like our wall in our room. Okay, one of our walls. And then finally, the XZ plane. So this guy right here uses the x-axis and the z-axis. That's kind of like another wall, different wall. Okay. Hopefully that makes sense to you. I mean, think about your room. Okay, I've got the floor, I've got a wall over here, and I've got a wall behind you. So think about it that way, and it shouldn't be too bad, I would imagine. All right, so let's go ahead and do this. So plot this point in 3-dimensional space. So here, this is my x, this is my y, this is my z. Now, I don't have a coordinate I don't have anything up here for me, so I got to do a little bit of freehand sketching. So I'm going to draw my X. Okay, so I just like to do my Z-axis and my Y-axis first. So here, positive Z goes up top, positive Y goes to the right, and then I'm just going to do my X kind of at a diagonal going through the center, something like that. That way it looks 3D. Now you might have to practice it a couple times, but this is positive X up here. Okay, so I'm coming forward or going backwards. All right, so I'm going to just draw a few tick marks. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so I'm just doing a freehand sketch. It's not perfect. I'm not a Leonardo da Vinci or anything like that. But try. Now, you might, if you're OCD like me, you might erase this many times before you can draw it to where you think it's acceptable. It's not an art contest. Just do the best you can. You can print this off online, fine. Just 3D, axis, something like that. Google it. All right, so let's go ahead and plot this point. Let's get on with it. So the first number is positive X. So that means I walk forward. So I always start at the origin. Okay, so this point right here in the origin, you might want to call that, just to say what that is. That's the origin. So that's 0, 0, 0, and that's called the origin. Just like before. And we always start from there. That's our house. That's where we live. And when we have a new ordered pair, that's telling us where are we going? What direction are we walking when we leave our house? So we always start at the origin when we're doing this. So I go forward 3 units. 1, 2, 3. So forward 3 units. And then y is negative, so I'm going to go left 4 units. So 1, 2, 3, 4. Let's do that in a different color. So I'm going to come out this way 4 units. And if it helps you, do a dotted line. And then finally, my z is negative 2 units. So I go down 2 units. 1, 2. So I need to go down something about right here. All right, so my new point lives approximately right here in this space. Now, that's kind of hard to tell because, we're doing it by hand. There are computer software programs that can graph this nicely, but you get the idea of what we did. Okay? So that's that. All right, what does a linear equation in 3 variables looks like? Okay? What form does it take? Well, it takes this kind of form. It takes, all right, so we're going to have something ax plus by plus cz plus d equals 0. Okay, it's going to take that format. So here, a, b, c, and d are just simply coefficients. They're just simply numbers. It could be negative, it could be positive, it could be 0, etc. Okay? It could be fractions. And then what does a solution look like? Well, it just simply looks like an ordered triple, x, y, z, and it's going to satisfy the equation. That satisfies the equation. Just like we did in 2 dimensions, so no big deal. And what does a graph look like in 2 variables? Well, remember when we graphed in 2 variables, our graph turned out to be a line. Well, now when we graph in 3 variables, we're adding a 3rd dimension, so what we graph are actually going to be planes. We're talking about linear equations in 3 variables, so these are going to be planes. And remember from geometry, a plane is just simply like a flat surface that extends in all directions forever. So imagine your sheet of paper that extends in all directions forever. It's perfectly flat. Okay, so let's do this. Okay, now, we can't just jump right into graphing these, okay? Because one, we're not using technology. We're doing this by hand. Your calculators, the TI-83, 84, cannot graph in 3D. Graphing in 3D is actually kind of a new thing on the public domain, okay? Private sector's been able to do that for a while, but school is not very much. So what we're going to do is we're going to graph. That's what we want to do. So we find the traces. We have to find what's called the traces. And we're going to have 3 traces. There's 3 of them. Okay? So remember, we're starting with this type of equation. AX plus BY plus CZ plus D equals 0. Now, how do we find the traces? So there's three types we want to have. We're going to have what's called the XY trace. The XZ trace. And the YZ trace. So what we're going to do to find the XY trace, we're going to let X and Y be 0. That gives us Z as some number. Z is just going to be some number, okay? So that's kind of like our Z-intercept, so to speak, okay? We're going to do the same idea for the XZ trace, but now we're going to let X equal 0 and Z equal 0. So that means Y is going to be just some number. Don't know what that is, but essentially we're finding the Y-intercept now. And then finally, you probably have already guessed what we're going to do. For the YZ trace, we let Y equal 0 and Z equals 0, which means X is going to be some number. So essentially we're finding the X-intercept. This is super important. Once you have all three of these numbers, all three of these intercepts, we're just going to draw a little triangle that represents our plane, and then we're done. It's that simple. Okay, so let's actually do that. Okay, so sketch the graph of this. So first things first, we have to find the traces. So first, find the traces. So we know there's three of those, so I'm going to do the XY trace first. And we know that means X is 0 and Y is 0. And from that, so everywhere in this equation, everywhere I see an X, I'm putting in a 0, and everywhere I see a Y, I'm putting in a 0. So I end up with the equation 4Z equals 12. So Z is equal to 3. So that's my Z-intercept, for lack of a better term. Okay? So that's the first one. On the next one, I want to do the XZ trace. So I know X equals 0 and Z equals 0. So I'm just left with the equation, cover up X equals 0 and Z equals 0. So I'm just left with 2Y equals 12, which means Y is equal to 6. So that's my Y-intercept. And then finally, the last one, YZ trace. Okay, so we have Y equals 0 and Z equals 0. Okay, so Y equals 0 and Z equals 0, so just up with, so 3X equals 12, which means X is equal to 4. So now I have my traces. Okay, it's not that hard. So now what I want to do is actually sketch my graph, and I want to plot these three intercepts. So I'm just going to do a quick sketch. Nothing fancy. So something sort of like that. Okay, so X equals 4, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's do another one just in case, because we go all the way up to 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, so the first one, X equals 4. So 1, 2, 3, 4. It's right here. That's X equals 4. All right, the next one, Y equals 6. 1, 2, 3, 4, 5, 6. So Y equals 6. And then the last one, Z equals 3. 1, 2, 3. Okay? Now what I want to do is just connect the dots. So now what I have is a three-dimensional object, a three-dimensional plane, because remember from geometry, it only takes a minimum of 3 points to determine a plane. So this plane that I've just drawn represents this linear equation in 3 variables that we just came up with. Okay? So that's pretty neat. Now notice that the plane is flat, perfectly flat, and we have to imagine that it extends out in all these directions forever, just like the plane in geometry does. Now, we can't really graph anything curved or loop-to-loop or anything like that by hand. That's where technology comes into play. Okay? But that's pretty neat just to be able to do a sheet of paper in 3D by hand. I thought that's pretty neat. Hopefully you do too. We're going to do another problem. So let's sketch the graph of this thing. Now, go through the process again. Find the traces. So we need the XY trace. Anytime it says sketch the graph of a three-dimensional object, you got to do the traces, okay? So that just means x equals 0, y equals 0, which means just looking at 2z is equal to 8, so z is equal to 4. Okay, go on to the next one. So that's my xz trace. So x equals 0. Or z equals 0, excuse me, which means I have negative 2y equals 8, so y is equal to negative 4. And then finally the last one, my last trace, is my yz trace, which tells me I'm just looking simply at y equals 0 and z equals 0. So I'm just looking at the equation x equals 8. Now I know I'm going through this really quick, but you know how to substitute in and solve and simplify, so I'm not going to demean you by wasting your time with that. If you need help with that, go back and look at a previous video or come talk to me in real life. Okay, shoot me an email or something, get help. So now what we want to do is graph these points on our grid. Okay, so something like that. So here's positive y, positive z, positive x. And I need to come forward at least 8 units of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and again, this is just a sketch. Okay, so my first trace told me x equals 8. So 1, 2, 3, 4, 5, 6, 7, 8. So that's x equals 8. Okay, my next trace told me y equals negative 4. So I go to the left. 1, 2, 3, 4. So right here, so that's y equals negative 4. And then my last trace tells me z equals positive 4. So 1, 2, 3, 4. So somewhere about right here. So z equals 4. So connect the dots just like we just did recently. Okay, so it's something like that. This plane is kind of like looking at a sheet of paper straight on edgewise. So, but that's the plane. Okay, that's our sheet of paper. 3-dimensional. Hopefully this is making sense to you. It's not that bad once you get the idea of what to do. It just takes a little bit of work. That's okay. All right, more on linear equations. So how can we use function notation to write a linear equation as a function of 2 variables? So remember, so what we're going to do is just simply get z by itself. And if you remember back to one variable, when we had y by itself, instead of y, we said f of x. Well, now instead of z, so instead of z equals, we're going to write f of x comma y equals. Because it's going to be a function of function determined by both x and y. And our output, so now we have 2 inputs, 2 things we're putting into our machine. Our x values and our y values. And our output is our z's. Okay, so just like we did in two variables. F of x was just another name for y. F of x comma y is just another name for z. So let's do an example. So write this as a function of x and y. So anytime you see a function of x and y, all they're saying is replace, so z is equal to f of x comma y. You want to replace those, okay? And then evaluate the function. So let's get z by itself first. Let's do it one step at a time. So just write down what we have. So 3x plus 2y plus 4z equals 12. Get z by itself. So I need to subtract 3x and also subtract 2y. Okay, cancel out. So I'm just left with 4z is equal to negative 3x minus 2y plus 12. And finally get z by itself by dividing everything by positive 4. Okay, so z is equal to, now I have three things on top in my numerator, so all three of those numbers are being divided by positive 4. So be sure you take care of that. So I have negative 3/4 x minus 1/2 y plus 3. Now I went ahead and simplified as much as I could, okay? So we have z by itself, so that's great. But now what we need to do, is to replace z with f of x, y. So f of x comma y is equal to negative 3/4 x minus 1/2 y plus 3. Pretty easy. So what that means is I have a function and my input variables, I have two input variables now, x and y are my inputs, and z, or f of x comma y, is my output. That's what comes out of my machine now. So we were asked now to evaluate when x equals 1 and y equals 3. So we're evaluating fxy at x equals 1 and y equals 3. Okay, so everywhere I see an x, I'm going to put in a 1. Everywhere I see a y, I'm going to put in a 3. No big deal. Let's just make sure we got it down right. We do, so let's go on. So what we're going to have now, I have f of 1 comma 3, because that's what I'm putting into my machine, and I'm interested in what comes out when I put that into my machine. So everywhere I see an x, I put a 1. So I have negative 3/4, because negative 3/4 times 1, minus 3/2 plus 3. Now you might want to use your calculator here. I would advise it. Just be sure if you do use a calculator, type your fractions inside parentheses. So let me grab a calculator real quick, just in the interest of time. So I have negative 3/4 inside parentheses. Make sure you're typing it in correctly. Minus 3/2 inside parentheses plus 3. And I get 0.75, which I'm going to turn into a fraction. So that's 3/4. So to write our final answer, so we know when I plug in my input as a 1 for x and a y for 3, then the soda that comes out is 3/4. That's how you would write your final answer there. Pretty easy. Just like we did in 2 variables, now we've gone to 3 variables. And that's it for graphing and solving equations in 3 variables. Hope you enjoyed it.